Hey folks, I just realized that I did not set up my code window. So let's do that. And you guys kind of caught me in the middle of something, specifically that I am futzing around with the idea of moving from a height scale to a minimum height and maximum height to give me a little bit more control, right? Because all of this rewriting is about having control. Howdy, Pete Furious, by the way. Yeah, that's the big thing, right? We want control, and so I'm trying to change that control to something that's a little easier to use. Octave noise 2D. So I'm just going to really quickly toss that in, and then we'll actually get to what I've been meaning to get to. Let's see here. Min height, max height. So we want to take the noise, which is a -1 to 1 range. Let's see here. Noise equals noise plus 1. Right, because we're going from a we're going from a -1 to 1 range, so now we're going to go 0 to 2, and then cut it in half. So now we're going from 0 to 1, and then it's actually pretty easy at this point to, let's see here, get the min height first. See, all that work is paying off, because it's nice and easy to make changes like this. I love it when the work pays off. Howdy folks, all you lovely people in chat who are able to join me today at this somewhat earlier hour than usual, but that's okay. Because I got stuff to do, and I'll be here getting it done. Let's... min height, there we go. So now we're going from 0 to 1. Let's see, noise times. So now we're going to be going from 0 to whatever the range is, and then we need to add min height back in. Right? Add min height? Yeah, because if it's a negative number, we'll bring the range back down. And then we're going to do our poor man's fmod, and that should be that. Watch me just break everything right now. Don't break. Please. No, that looks good. Okay. Cool. And I got all the skirts in, as you guys can see, so all the terrain actually has a correct setup of all the various skirts. And the funny thing you may note, for those who are able to tell the difference between the frame rate, remember before we were sitting at about 55 frames per second, and we're still sitting at about 55 frames per second. There's no big difference here, which is really cool, because it just goes to show that really the poor optimization that's happening here is not the fact that I have so many polygons on the screen, right? There's even more than before, and that's not the end of the world. The big problem here is actually that I'm sending so much information down the wire in little bits and pieces that it's just making it difficult for the system to do its job correctly. Instead of sending it one large chunk of data, I'm kind of feathering out all the little bits at a time, making it rain data, so to speak. So nice to know that that's kind of our, and whenever I lose focus, obviously the frame rate drops pretty significantly, but that's not the end of the world either, because that's expected. Okay, cool. So we've got Alright, so that's in. I'm just going to commit that real quick, just to make sure that if I do revert for any reason at all, from biome height multiplier to min and max height. Just in case I lose my work for any reason, or if I decide to revert, that I don't accidentally end up reverting these changes as well. Because there are some little significant things here and there, just to make my life a little easier. And it's nice to have them all in one place. And nice to have them committed all at once too, so that each change is very, very discrete. Okay, cool. So in that goes. And we are on revision 130, making good progress. Granted, some of those revisions are tiny, tiny little changes, or oops, I forgot a file, but that's not the end of the world either. So let's see. So we've got the terrain in, and it works well enough, but you'll notice we have some problems. Whoops. And the frame rate is not a problem, so I don't know why I opened that window up. I guess it's just habit. Let's close that. So issue number one, actually, issue number one is a frame rate issue, right? When I click and drag this over and move it around, check out that frame rate. We're dropping to only a couple frames per second, right? And that's painful. And I know the cause of this, right? Especially when I stop moving, we're fine, right? Then I go move it and it, oh god, pain. So the big thing here is that in this case, because we have so many cells, because remember the Voronoi cells were pretty friggin' huge, right? Because we have so many cells now, we're still iterating through every single cell when I'm doing the raycast from camera out to terrain, and that's a lot of cells to dig through. So that's one problem that we need to fix pretty much immediately. The other one is that this is going to be a bit painful for the Pathfinder to look through, because all these tiny little cells in here are going to cause us some trouble. So that's another thing that probably requires some, at bare minimum, some cleaning up. And maybe we could do some range limiting to make sure that they don't look too far outwards when they're looking for a path. Let's see, other things. You'll notice there's these big cliffs where the height difference is between some of our terrain. And that's not exactly something we want either. Actually, is it just me, or is the whole thing lifted up a certain amount as well? Like, this should be able to have a pretty standard low height, I thought. I thought it at least had a 0 for a minimum height. Let's look at that. Hey, look at that data file I just had open. Yeah, and you'll notice that the minimum height of mountains is set at 0. Granted, it doesn't need to be -0. Let's just nuke these. So it goes from 0 to 3, and that seems fine. I don't actually understand why this is going wrong. Let's see here. Take a quicker look. Just real quick like. The cell, let's see, this will be somewhere probably in our generate mesh function. When we have our biome information. And or I guess the other spot it could be in is the actual terrain generation itself. That would be the other place for us to look. And I'm guessing it uses this get terrain height function. So, okay, just to quickly look through here, return random values in a -1 to 1 range. So that should be pretty straightforward. Algorithm is So this is someone else's code. This is something to keep in mind. You'll note this is not my code, but it's included in my project because, and I actually, oh, here it is at the very top. You'll notice this is a GPL license. So make sure, one thing for anyone who's programming and uses open source code, that you include the license at the top every single time. Not only so you know where you got it from, usually they have, here's our source, but also just so anyone who ends up looking at your code later can't say you copied their code or, you know, claiming bullshit around copyrights. Don't even, you know, bother with it. Just make sure if you use something open source, the license is included somewhere, and it's probably good to keep a note of the license somewhere else as well. I've got an actual text file floating around that has all my open source sources, and so that's always something good to have. So let's see here. Scaled raw simplex noise returns values in the -1 to 1 range. Okay. So when we say get terrain height, here's our minimum and maximum heights. And I'm just going to dunk a breakpoint in here. Oops, that is not a way to load up the world. Come on. There we go. So the biome type is forest. I wonder if I can just mash F5 a whole bunch of times. Still forest? No? Okay, I'm going to hold F5. We'll see if that helps. Forest. Really? Plains. Watch. Like, forest's going to be at the very end. Or, sorry, not forest, mountain. Well, I guess any of these will do, right? Min height, max height. So forest has a pretty standard minimum height, maximum height. So we generate our number between 0 and 1, or -1 and 1. We push that range from -1 and 1, and we shove it over between 0 and 2, and then we're going to cut it in half so that it goes between 0 and 1, which is what we're doing here. So okay, our number goes between 0 and 1 now. Let's see here. I'm just going to look real quick. Our noise starts at 0.09. So this should make this number larger, but not by much. 0.5, 0.0. Okay, yeah. So something that was at 0 before, because remember, it's based on the range. So something that's at 0 is actually going to be in the center of our range and get translated up to 0.5. So, okay. That's above 0.5. That's an expected value here. And our actual range is 2. So we're going to multiply our range by 2 and then add back in that negative number. So it should take that 0 to 1, push it back to 0 to 2, and then subtract 1. So it goes back to, oddly enough, -1 to 1. So it looks like this function does what it's exactly supposed to. And I have somebody on Steam asking me about the D&D stuff. that words asking me about some of the stuff that we decided on earlier, and then that gets flattened out to 0 because of our poor man's fmod. So this looks like it works, oddly enough, which makes me really curious why this is breaking down for these mountains, right? You'll notice this kind of crazy height difference here. Here, I'm just going to toss... Let's toss if biome equals k biome mountain. Actually, printf isn't going to work because printf isn't included anymore. Bool test equals true, and we'll just put a breakpoint on that. Okay, so we now know our biome is mountain. Minimum height 0, maximum height is 3. Okay. Noise, once again. These are really bizarrely small numbers, is the only thing I'm noticing. Part of me wonders if this is scaling it down to 0.1. Let's just try something for a minute. Whoa, that's bizarre. So this just looks like a much more pure version of noise. Makes me very curious what's going on. Almost looks like you have a city over here with... This is something that for like marshlands might look really cool. Okay. This times 0.1. Let's try a few techniques for kind of slowing down that change. Interesting. Okay, well, I think I know a little bit more about what this function does. Problem is, it's still generating the same problem every single time. And I really was hoping this wouldn't turn into something big, but it's looking like it is. Scale. What is this scale used for? And specifically, okay, here's the scale. So it's the frequency, and the frequency is passed into this raw noise. Interesting. Okay. I'm really curious what happens if I just use the raw noise straight up. And all it takes is an X and a Y? Sure, let's do it. Why not? Do a little science. Just to see. Ha! So this is what raw noise looks like. Specifically, I guess I should say, you can kind of see the basic circles and the interpolation going on here. That's very, very simple. I kind of like this in some ways, but it's also just not the end all of what we want, which is fine. So my big problem here, more than anything else, and the reason why I'm fighting with this so much, actually, let's undo this, because I didn't mean to. I didn't mean it, code. I'm sorry. The big thing that I'm having trouble with is that you'll notice, okay, starting here, you've got this flat-ish terrain, and you've got this kind of matching area over here. And then you come over here, and this is really, really problematic because it starts at such a crazy height that no one could ever scale this, and there's no easy or controlled way for us to have the villagers be able to scale this. And so that's why I'm kind of fighting with my inability to shorten it. Because what this should be is not just a bunch of stuff that's kind of raised, but it should be a bigger range more than anything else. Which is why I'm really curious what's going on here. So, min height is 0, max height is 3, and that's what's in our data file. So that's correct. We take our noise, which is some small-ish number. So 0 in this case, let's see, 0 would be 1.5. Okay. It's actually, well, no, now we've shifted it and moved it around. So it's like, it's going to be a little under 1.5. Because this should have an expected larger range, right? We're multiplying it by this 3, and then we're adding 0 back into it. 1.3 becomes 1.20. Atex Studios' active noise is definitely not part of the C4 engine. He has a random number generator that's pretty freaking good, but it's not, definitely not octave noise. Specifically, it's not simplex noise. That's because that's what I'm using in this case. All right. This just is bothering me because I'd like to be able to have noise values that are a little, I don't know, a little closer to home. I guess the other thing I could do is just not have it be such an incredible height difference. Or I could have an equal height on both sides is the other thing. Specifically, let's see here. Where'd that data file go? I could say, well, you know, it's... Gosh, but from 0 to 3. Yeah, so I guess the other thing I could do is be like, well, let's just make it like -1 to 3. And that'd bring us down a little bit, and also I'm not sure I like that as much, but it's something I'll think about and fight with and work with a little more. The other thing is we need some interpolation in here so that it's not hard edges between so it's not a hard edge between the two biomes, but instead more of a gradient of each. That would be really the ideal here, is that we say, well, you're kind of close to a forest, so it's going to have this like smooth upwards transition into a mountain, right? That's, of course, the like perfect case. So it's a different library? Yes, it is a GPL version 3 library that I am using. So public source stuff. Pretty easy to find. Simplex noise is, well, as the name kind of implies, I guess, it's a simple thing to do. And since we're cleaning up the terrain stuff, why don't we get this interpolation in here? So we could do what Moldy Moss is suggesting. If your noise is between 0 and 1, just raise it by a power and dampen it out. So what he's suggesting is you square the number, or you know, whatever the number, and because it's between 0 and 1, it's not going to break out of the 0 to 1 range. in fact, what's going to happen is you're going to see the graph dip down quite a bit like this. And what that ends up doing is it's going to dampen out how the terrain looks in a lot of places. My only problem with that is it would also dampen out some of the major height differences. Now, that's not the end of the world. That's actually kind of nice in some ways, because that would mean that most of the terrain is following a better curve. So I'm kind of tempted to go for that. Kind of. Well, let's see. I actually wonder if there's even something in the math library for that. Yeah, of course there is. Okay, so here's our base. And let's say, first off, this is our base. And let's say our exponent for now, we'll just try 3. We'll cube the number. Just see how it looks. My curiosity is getting the better of me. Oh god. So, the one thing that's doing is because that's dragging all the numbers down, it's dragging a lot of our terrain under the water. You'll notice that the mountains are one of the few things able to kind of keep their head above water. Interesting. Oh. And now I think I understand kind of the issue with just throwing it inside one of these like functions and kind of hoping it works. So the issue is we're doing the conversion from -1 to 1, and we're swapping it from 0 to 1, and then we're doing the curve breakdown, so it's not linear anymore, it's now this gradient. And then if you think about, let's see, actually it might be easier to just MS Paint, right? Yeah, let's just do this real quick. So here's our graph, and usually our terrain looks like this, right? It's got a nice linear curve, and then we have our multipliers kicking in, so it messes with it in various ways. And when we, let's see, colors. So when we do the power option, it causes our graph to do this. But the one thing to keep in mind is that our terrain is going to be underwater if its height is anywhere along this line. And so where before a fair hunk of our land was kind of equally under and above water, this is dragging it back under. It's going to drag it underwater because the water's at a fixed height, as opposed to this function, which is just kind of modifying the output of our random number generator. That's fine. It's not the end of the world. I'm not actually too interested in dampening it. I really would like to do some kind of interpolation, really, because dampening, while nice, let me think, because dampening it might solve this problem. Might. If the noise is from -1 to 1, use a power less than 1. So you're saying put it over a exponent of some kind. Maybe. Once again, I'll look at things. You never know. It might generate something. Oh, also, first we'll do this. This is probably going to be, yeah, as I expected. That's fine. Oh, I know what to do. Okay, I see. We're going to take this. Here's our base. Here's our exponent. Oop. Okay. 0.3. Can you even... Yeah, it takes floating point exponents. This is bizarre. It's found a cell without biome information attached to it. That's really bizarre. What's its height? Oh, the height is not defined. What is happening to my height? Oh well. Yeah, I don't really want to just kind of dampen it. That's not what I'm going for here. So let's just tear that dampening stuff out, because it's just not what I'm hunting for here. What we really want, and what should work the best for us, is some kind of interpolation. So there's a couple ways we can do this. One is we can see what's next to us, and we can check just kind of immediate area. We could, let's see here. I'm trying to think of a good way to do this, because we could generate way too much data for this, and that would be kind of overkill. This is something we should only generate once and then hang on to it. And you'll notice right now, every time we grab terrain height, we're recalculating it every single time. Whoops. And that's complete overkill. So, especially since we have an elevation component inside each cell, we should honestly be doing all the hard work and then just fixing it up once and leaving it be. So let's see here. Set cell elevation. So here's our spot where the cell elevation is kicking in. What? No. Really? Sorry guys, I'm a little lost. Where did this... Am I not using my get terrain height? No, I'm really not. Holy heck. Well, that explains a lot, first off. No, here's the get terrain height function. Yeah, okay. Cell biome. I don't know what my brain is doing. Sorry guys, it's on and off today. And it's just kind of messing with me. Maybe I just need coffee. Need to start making myself some coffee. That might be on the list. Alright, so every cell is doing its own height generation during the fact, right? We're generating all of the information for the cell immediately. And I think what I'm gonna do... Yeah, I think I'm gonna move this out of here. Because all this is setting is our elevation. We don't really need it to do anything more than that. So when we tell it to create a cell graph, I'm tempted to go through and find each cell after the fact and then do some interpolation on the area you have been in. Now the only thing this won't work for, and this is kind of me looking forwards, trying to see if I can keep kind of the needs of the project in mind, is that eventually we're going to break this up so that, first off, a cell is a set area, and secondly, so that we can interpolate between areas that are connected, but not... they're within the same graph. I need to, essentially, this boils down to I have to be able to find a way to group some of these nodes together. kind of wish I had written this in a better way such that I could more easily create a hunk of vertices and do all the work at once. Because that would also save me some trouble right about... Well, no, this would cause me trouble right now. Well, one thing at a time. It's So we'll have to define a range at which what is near it modifies it. So I guess the obvious thing to do first is actually just cell graph, cell array, get element count, and then we need to pull a single cell or something like a terrain cell into this. So SpamSack, I am using a variation on Perlin noise called simplex noise, and it has the same gradiated effect. The reason it's not completely perfect is because I want different height ranges for different areas. For example, I want the mountains to have a higher height range than a flat plains area or a forest area. And eventually, we might even go so far as to say, well, this forest area is going to be offset down, or this mountain is going to be offset up. Doing things like that later will make the terrain even more interesting as we go through. So, let's see here. And I'm just moving things around every once in a while too, because I'm making sure that I have kind of a more appropriate set of information in a more easily accessible way. For example, cell array I. But it shouldn't be just I, it should be plus I, because we want to pull pointers out, because we're modifying things. So if we're not modifying things, it's fine if we use references, right? But in this case, we want to actually make sure that we're pulling pointers out. Gosh darn. So the only thing I'm having trouble with now is, okay, I can get who I'm attached to. And I guess I can just use the cell list to pull each of my adjacent neighbors. Yeah, that'll work. So we grab our cell, and then we need to grab I'll use E, because we're looking through edge indices. E is less than the cell's edges. Specifically, we need to use our graph and get a cell edge. Get neighbor cell. There we go. And we're going to use our neighbor index. Obviously, if the neighbor is null, we skip them. And if the neighbor isn't null, we need to factor part of their information into our information as well. So let's just say that each cell we work with, we're going to have to create some amalgamation of information here. Specifically, how do we do this? Let's do a float array, and this is going to be our, we'll call it a percentage array, and it's going to contain a number of elements equal to the number of biomes we have total. This will make it easy. So then we'll say, okay, first off, the cell's own biome should get added in, right? So we say, oh, we're made up of percentage array, biome type, and we'll just add 1. And then maybe if we take everybody else in as a half step, just to make sure that it's not, I guess, or the other thing we could do, because, oh, this is gonna hurt though, because this has to be range based. So if we only look at the immediate neighbors, what you'll do is you'll end up with a one cell lead in into every change. So we have mountains here, we have forests here, right? We have the 2 height differences. Currently there's no lead in, so it's just this big sheer cliff. Now what'll end up happening is we'll see a half step between the 2 if we average them together. And I'm not really sure I like just a half step. I think I want more of a gradient. But that would mean I'd have to store things in the cell graph somewhat differently. Because right now the cell graph is just this like arbitrary set of cells. Oh gosh. So at some point in the future, I'm going to have to come up with a cell group. And this is where things are getting a little complicated. If only because I'm trying to future-proof, right? Also, I'm trying to make sure that this information is not so crazy, like, complex that I'm going to have trouble editing it later. And then the other thing is that I'm trying to also make sure that I can easily access this data, because I need to be able to easily access it for my tools as well. Each tool needs to be able to quickly and easily grab what cell they are standing over. So let's think here. If we took this out of an array, right? If we took all these cells out of this array, because every cell is going to have a unique center. So if we created a hash map using cells, instead of just dumping them into an array, we dumped them into a hash map, we could then somewhat quickly and easily deduce where we're coming from, right? We'd be able to take our current position, we would move to the nearest center, and then using that center, we would look up what cell we were hunting for in the hash map. I like that better already. Let's look at the engine's idea of what a hash map looks like real quick. Real quick like. Utility library map. So first, last, which gives you kind of the ability to iterate through things, right? Nice and simple, just standard first function. So first, last, returns a Boolean whether a certain member object is a member. So the other thing we want to make sure is that we also don't break current functionality, so that we are able to hunt down what we need without changing too much of the rest of our code either. So let's see here. You are going to become a map. Let's see, can I just put this over here? Yes and no, because the moment I click here, it's going to go away. Oh well. A map of cells, and because, remember, this engine, all of its data structures are invasive, so you have to subclass from them And it's not map, it's actually map element, sorry. And what this does is this inserts member variables and functions and all kinds of other stuff into the class that we are using. That's what this map element does. And that allows it to be usable by a map type of the matching type. So, right, and because our map needs a certain kind of setup, we need to make sure that it has this matching set of functionality. Specifically, we need to typecast something and call it a key type, and then we need a getKey function and a getKey. Let's see, we need a getKey function. Oh, and then we need a good way to generate our hash. Nice and simple. So for here, typedef, probably just a straight floating point number is going to be our output. And we'll have to figure out a way to calculate this floating point number. Either that, or we could just say, it's our point 2D. That might not be the end of the world. We'll see if that ends up complaining too much. And a function named getKey that has one of the following two prototypes. Sure. Let's use this one. I like it. I like it a lot. Alright. We're just going to return our origin. Will that work? Really? Oh. This typedef should not be private. It should actually be in the public space. Also, what are you complaining about? No operator plus matches these operands. Fair enough. What is this? This is us creating the cell graph. Oh, this is the percentage array stuff that I was hunting for. The other thing that this is going to break, and I didn't really consider this until now, is that this is going to break the cell edges. Cell edges currently access your, I guess your index, and they access your index via just standard index, right? Standard indice sets. I should have thought about this a little more before starting the stream. But, not the end of the world. Not at all. I'm tempted to go the Minecraft route. Call it a chunk. And a chunk will be built up of a bunch of cells. The only thing about chunk is that chunks are, at least in my mind, because of Minecraft, they're inherently 3D objects, right? You have a chunk is like a, not just the 2D space, but also the depth. And this is something that really doesn't have depth, right? This is essentially just a 2D height map we're generating. And so the big thing here is that I almost wish I had a really easy way to turn this into a texture and then back. Or into just a flat grid, right? That would be nice too. If I could just say, this is just going to kind of fit into this flat grid, and I'm not going to care about actual origins until we're done with the whole mess. Something like that would be fantastic. So why don't I do that? Let's do that. Let's. I mean, I'm trying to think of reasons not to, but why not? I mean, let's think here. Are there any major downsides to at least using a two-dimensional grid for generating our terrain? Not really. And Chocma, I'd be careful with naming anything a map, if only because programmers use a lot of structures that are named map or hash map or things that kind of are like that. If I were to read that there was some class named map, I would kind of immediately assume it was some kind of hash map or some kind of key value associative array at the bare minimum. And so I'd be really careful about naming something map. C4 engine is not free. You have to purchase a license to make use of it. It's a great engine. I love it to death. It also has some shortcomings, so it is not the end-all of engines, but at the same time, it's a really good engine. Very, very cleanly architectured and clearly well thought out. Unlike what I'm trying to do right now when I'm slapping this game together. So let's think. I want to generate kind of a 2D... Ooh, I'm liking this idea the more I think about it. In fact, why don't I leave the information in a 2D grid? Right? So, okay, we're gonna do this. And the more I think about this, the more I like this idea. So right now we have a single cell graph, right? And this single cell graph is extremely limited. The cell graph has a problem of being... First off, it's the only one that can exist in the world. If you look at our game world class, we hang on to that one cell graph, and that's it. That's the only one that can exist. So I don't like it as it is, because we're extremely limited to what is inside this cell graph. So that's problem number one. We need to be able to make this extensible so that as you explore new regions, right, as your characters wander around and explore, that they can never walk off the edge of the map, because simplex functions and this 2D noise that I'm using can go on forever, right? There's no good reason why we're limiting ourselves to the system that currently exists. So sorry, dog's making funny noises. So I think what I'm going to do is first we're going to create a grouping. I don't know if that's going to continue to be named cell. Excuse me, dog's ripping up my stuff. Apollo. No. No. Do it. Go play outside. Go play outside. There we go. Let him go play outside. Have his fun instead of tearing up my carpets for his fun. So, group. A group. I think I'm gonna, let's see, cell chunk, cell group, cell something. We'll see if the name is alright. Also, I don't know why this is in here. Let's just architect this whole thing just in front of us, so we have an idea of what's going to be happening, and then we can do it. Right, so we're going to keep the cell graph, or the cell whatever. Whatever the root of the cell is. The cell, the thing that contains all of the cells, right? Container doesn't sound right. Cell system, right, I like it. So we have a cell system, and the cell system is going to contain a number of cell groups. And each of these cell groups is going to have the following. It'll have all of the cells that are inside, and it's going to have them in a 2D grid. And the other thing it's going to have is an origin, so that you can quickly and easily find, not an origin, let's say it's got a range of points. And this will be its, just the land area, origin, area, range, whatever. So I like this for a number of reasons. Number one, it's really quick and easy for us to find what cell group we're hunting for. In fact, I'm so tempted that I actually want to say that we're going to have a map of cell groups so that we can hunt down which cell group is where based on a hopefully pretty easy range. Maybe even break this down into an integer 2D just to make my life even simpler. So, okay, we have our cell groups, and then our actual cells. I like this a lot better already. The only thing I'm not sure about... Only thing I'm unsure of is we still need an array of cell edges to live somewhere. Also, it would be nice... So the cell group would be the one who contains all the vertices for these cells. An array of, vertices. And then we have all the edges. And the reason I want edges, or the reason I put edges outside of the actual cell group, is that the edges can go between each group. Man. What started as one little rewrite is turning into another bigger rewrite, and then another bigger rewrite on top of that. This isn't what I meant for this to turn into initially. And what I'm kind of tempted to do is put this off and do this off stream, because it's going to be boring as all heck to watch me rip stuff out and redo it all over again. I really don't want to subject you guys to that. Although the problem is I can't really get gameplay going until I have the terrain in a working state that I like. Oof. Heavy stuff. Also, actually, vertices would be something that would also be shared between all of the existing cells. Starting to see how this is kind of a bigger subsystem than I'd like it to be. Right now it's kind of nice and contained. Let's see. Graph, and the graph is nothing more. Yeah, the problem was the first time we wrote this, this system was kind of initially written by my partner, and he, in writing this, we weren't exactly terribly... We didn't have a lot of forethought here. We kind of shot ourselves in the foot by thinking too small. Although then again, also at the time, graphs were, you know, a Verneuil cell was pretty freaking large, and so that wasn't really a big problem. Because we didn't have a ton of cells floating around. Now, a 1x1 square is, oh, where's my current resolution that I'm using? It's pretty freaking huge. It's like... create cell graph, range, build terrain. I'm calling that in game world, and that means... Yeah, so right now, 1 square unit is 16 cells. Oh my gosh. That's overkill. That's really... not overkill, but it's big. But I think this is what has to be done in order to make this, an extensible enough system that you could have a guy walk for a significant amount of time and not run into an edge is really what I think I need. It's either that or I keep the current system as is and we put up with a stupidly long terrain startup. Specifically, we say, load the world, and then it would sit there and chug away and generate all our vertices and do all the hard work. But even then, we still need to break these up into vertex buffer objects that are larger than what I currently have. Otherwise, my frame rate's going to drop even further, and that's not something we can exactly tolerate at the moment. So this isn't something you run into too much in an actual professional setting. This is something I'm running into because I had a lack of foresight when we first put this terrain system together. Now, granted, a lot of programmers run into this, right? They have an idea, they set out to do it, and it kind of turns out that once you program something once, by the time you're done writing it the first time, you now fully understand what you're trying to do, and it's a lot easier to go, oh, well, now that I know how this should work, I should now be able to do it twice as good later, twice as well. And then you can go back and rewrite it again if you really, really have the time to. But in most cases, in a professional setting, you also don't have the time to do that. An array of cell edges, an array of cell vertices. I'm also trying to think of ways to reduce the amount of data that lives in here right now. Such as, like right now, all these vertices might not be necessary. Might not. Well, then again, we need them for edges, though. So, yeah, nope. Let's start. Let's dive in and get as much done as we can today. Kids' gloves are off. We're writing this for realsies this time, and hopefully, if we do this right, there are some big advantages. One, cell groups will be something we will be able to dynamically create, save, and load. Right? That's a big requirement. In fact, I'm going to toss a requirement list at the bottom of this architecture here, just so I have an idea of what I'm really shooting for. So we want to be able to dynamically create, save, and load cell groups. Everything else can go to hell, right? But the cell groups, we need to be able to load and save. Now, keep in mind, this doesn't currently include unloading, and that would be difficult. That would definitely be difficult. But that is something we might be able to do as well, especially for some poor sap who has, you know, not a ton of RAM. Because, okay, right now, what cells are... Let's do a quick calculation just to see what this looks like. A cell is, by default, we've already got the terrain in the system, so that's one pointer. And then, what else? So, we're going to need each edge. So each edge is made up of 2 vertices. So that's 2 more 32-bit integers. Each of those edges is going to have a color. 32 by 4 is another 128. What else? Is there anything else that's attached to those? Elevation, I mean, each of their own positions. The problem is there's a lot of data in here. That's why I like the idea of being able to also unload it. Even though this makes it a much larger task, it also allows us to keep our memory footprint somewhat believable. As opposed to right now, it's kind of absurd. Just kind of, sorta. Okay. Luckily, we did a lot of cleanup last time of what is inside each of these classes, so we might not need to do quite as much work as I did with the last rewrite to get this all in place. So let's start with the most outer class, and then we'll work our way inwards. So I'm gonna rename this. Actually, maybe I don't want to right quite yet. Find and replace cell graph with cell system. Because it's not really a graph anymore. Like, our initial idea was a graph. The new one, not so much. 258 occurrences. Uh-oh. Do you still build? It looks like it changed things in the engine. That's somewhat frightening. We should make sure that we didn't. Or at least it changed enough that it feels the need to rebuild the entire engine. Man, I remember when I was in university, I had to rebuild this engine. You could walk away from your computer for a few minutes and come back and it'd still be chugging away. You'll notice it's actually almost done already. I am going to put some water on for coffee though, because coffee helps. So, Chuck was asking, when you unload a chunk, your little men can't live and work on those chunks anymore, right? Yes, that is true. Kind of the same way that Minecraft, the time stops. That would be the case if I ever unloaded a chunk. Why is dynamic loading of chunks a feature your kind of game needs? If we have... Why would that be something we need? Am I trying to do too much? Let's think here. So, if the memory footprint becomes too large, I will start losing the number of people who can play my game. Right? The system specs will start to go upwards, and before long, you'll find that one requirement isn't matching all the rest. So my CPU requirements will be here, my GPU requirements will be here, and then suddenly my RAM requirement is up here, because I'm just not using memory in a safe or efficient way. And that's kind of why unloading chunks is nice. Now, what you can do is that you can jump in and say, well, let's just make sure that there aren't any actors at all in that part of the world. And then when you reload the chunk, what you do is you say, okay, how much time has passed since this chunk was last loaded in? Let's do a quick simulation on all the stuff that could have happened in that amount of time, and update the chunk to our current time step so that time hasn't actually stopped. That's something that Minecraft doesn't do. That wouldn't be too difficult for us. If there aren't any actors in the game, or in that chunk specifically, then it shouldn't be too hard to fast forward time, because the only real things that could happen are a couple controllers in there that would then be able to say, oh, in that much time, I probably would have planted 3 more trees, and then those trees would say, oh, and in that much time, I would probably have grown up to be a full mature tree. And so you'd walk back into the cell and notice that a couple more trees have been there. And it saves you the processing of those trees running the entire time. And it also saves you the amount of RAM that it would be using as well. So it's... The big reason why I like the idea of unloading being in the system is only just to keep the RAM requirement in line with all the other requirements that we're keeping in mind as well. Because right now the CPU requirement isn't large, the GPU requirement is never going to be large. Right? Basic 3D terrain with 2D sprites, like this isn't ever going to need a huge GPU or CPU for the most part, if I do things right. So yeah. That's kind of my reasoning behind unloading and dynamic loading. That's why I would love to be able to have that kind of stuff. So okay, we have a cell system, and it looks like the only breakages were because I had still swapped... Let's swap you back to an array, just for now. And put everything back that I started. And let's see. We don't need this at the moment. Do you compile now? We also want to try and keep this compiling as we run through some of this stuff. Okay. This is obviously, this hunk of code here is not something we're going to think or use until way later anyway. So let's put all this back as well. Let's see. Graph is an undeclared... Oh. Crap. Looks like some of my... I should have... Oh. I see. Can I undo that? No. Not really. Not easily. Every place where it now says cell system, I'll just put cells. Let's see, replace that, that's fine, that's fine, that, not that, not that, that. It's like every other, which is just enough that it's a complete pain in the ass to do a find replace. And then that's fine, that's fine, that's fine, that's fine, that's fine, that's fine, that's fine. That's not. Okay. Is that all of them? Did I get them all? Looks like. It's compiling. It's a good start. Always a good start. Okay, next step. It compiles. Let's get it. Start swapping ourselves over. Create cell system. I accidentally changed a function. Create cell system. Oh, wait, no, it compiled. What am I talking about? Cell system. Whew, this is just a big thing. A big thing to do. Not the end of the world. Just a pain. Okay, I hear my water boiling. Be right back. Finish my coffee. I'll come back with my big jug of coffee in hand, and then we'll really dig into this and start it off. Alright, coffee in hand. In fact, I'm setting it down very carefully because I filled it up way too high. I do that far more often than I'd like to admit. Alright. Oof. Here we go. Vertex array, edge array. Now's my chance to reevaluate everything. So, we'll have a cell group. Right? Yep. And a cell group is a kind of map. Or, sorry, a kind of map element. Once again, invasive. Something that you actually don't run into much in the outside world is invasive data structures, and it's really funny that I hadn't honestly run into it much myself until I started using this engine. Gosh, I wish I could do two-dimensional two-dimensional arrays here. My brain is just like, yeah, sure, it should be easy, right? Actually, no. Not in C++ at least, right? They haven't added that as a like language feature when I wasn't looking, right? Every once in a while, you have to double check that everything you know hasn't been like turned upside down. I mean, obviously there's jagged arrays, but I want to make sure that they haven't added like C# style 2D arrays, because that would be sweet if they added those. Okay, yeah, multi-dimensional arrays look exactly the same as they always have, which is fine. Meh, whatever. Sure. Paint, come here. Oh, MS Paint. So, the idea here, this is kind of one of those cases where I want my drawing tablet. Drawing tablet, come here. Ooh. Because it helps me visualize. So, okay. You. Haha, alright. Now you guys get to see my real handwriting. So, there we go. So we have our game world. You also see me hit the undo button a lot. Okay, so we have our game world, and our game world is going to contain a pointer to some kind of cell system. Yeah, there we go. And the cell system, what we're gonna do, is we're going to take an associative map, which is going to associate, and I'll do this kind of C# style. We're going to associate probably point2D. We'll find a way to hash a point2D into a cell group. So what that means is we will have this set of hashes, and that's going to point an array that will contain all of our cell groups. So here's a cell group, and here's a cell group, so on and so forth. And then we'll have all the hashes on this side so that we can look them up quickly and easily. So okay, here's all of our cell groups, and each of these cell groups specifically is just going to be a 2D grid of cells, just so we can very easily find a cell we're looking for. So say, for example, there's a game tool, and this game tool is going to need to, like, say it's that ghost tool, or not the ghost tool, the storage shed tool, that when you click it, it puts down one of those storage shed 3D art. Come on, Rob, you can do it. There we go. It puts down one of these like construction boxes. So say a game tool needs to know, like, if a point is within a cell. So what it would do is, it would go into the cell system. Ooh, hey, suddenly I got a really thin pencil. Can I undo that? I don't like big thin pencils, or little thin ones. Size, here we go. Back to what I was at, yeah. So, okay, what this is going to do is it's going to grab our game world, right? Or actually, I'm just going to say it's going to go all the way up here and grab that game world. And it's going to say, first, get the group. And we'll write some helper functions to go with this. But we'll say, get the cell group that contains this X and Y. And then, from there, we can say, okay, we know that the min is here and the maximum is here. And we can just do the math and say, oh, well, if it's at 0, 0, which is going to be here and here, then we know we're looking for this tile here, right? The one that I'm about to slap red all over, that's our active tile. And then we can do some quick and simple checks that say, okay, you know, is the point inside this tile? Or is this going to contain, you know, the information we need? Can we get the biome out of it? Of that cell. Stuff like that. Important information we can then pull out of that cell. The other thing we can do very quickly and easily is say, okay, we're going to have a bunch of these attached to each other, and there's going to be a very thin barrier between them. And when you say, I need to pathfind from here to here, we can cut that into little bits and pieces. For example, we can say, okay, from here to here, this is the closest edge between the two. So let's try and walk from here to here. Let's try and walk from here to here. And as long as these edges match up as we expect them to, it should be actually, we can break up our pathfinding into little bits and pieces, and that should be helpful at all. Now, shared vertices will actually have to still continue to live outside. Whoops. Let's delete all this garbage that we're not using. Can I get a larger brush, please? Shapes. No, really? Let's go huge. That's not huge. Whatever. Close enough. Oh, there's just a select tool. I can just do this, can't I? Yeah, I can. Ha ha ha! Waste of time. Alright, so vertices will have to live probably alongside, because there are shared vertices between cell groups. That's the only vertices and edges here. These are the only thing that will live in the cell system itself. So here's all our cell system stuff. It's this guy. Actually, I should do it here. This guy, and this guy. If only because our list of vertices can't really be shortened much, right? It would add some data to a cell group. I don't know, if we're trying to do this in the best way we can, then this would be the way to do it. Gosh, this is a heck of a rewrite. I'm really just wishing I could find better ways to do things right now. For example, if I could just work under the assumption that we're inside a giant 2D array. The problem with some of these assumptions that I keep wanting to make and that I can't end up making is they generate a giant square of area. And I'm not really sure if a fixed map size is going to be something that's good for this game or not. Because if I can assume a fixed map size, I could throw a lot of this out the window real quick. We could simplify this to high hell. Actually, no, this is still a good system even for a fixed map size. So I'm kind of liking it more and more. The more I think about it, the more I'm finding that it is working out in my favor. Sorry, stirring coffee puts me off camera, apparently. Coffee is warm. Watch, I'm gonna get like halfway through the rewrite, the coffee's gonna kick in, I'm gonna be, holy crap, what am I doing? Why am I rewriting all this? But no, I think this is the way to go. Also, I'm gonna interrupt myself for a moment, because I saw a different kind of email just come into my inbox, and it is not the usual, someone new is following you, it is, Chakma, you sly devil, you. I see a donation of $10 from Chakma. Thank you very much, sir. I will add that to the growing bank account of this game. We're up to 15 bucks. Not much of a budget for a game of this caliber, but that's okay because. Honestly, we'll see how it goes. Thank you very much, though, sir. It is very kind of you to donate. Also, oh god, another one just came in. Spam Sack, you as well. Thank you for the $10. I have to keep noting this down just so I recall who did what and how much is attached to that account. Thank you very much, Spam Sack. It's nice to see both of you. Enjoying the stream so much that you hunted down that... Actually, I guess the donation button's easier to find now. I'm not hiding it anymore like I used to. But it's nice to have you guys doing that. Thank you very much. I will definitely get a beer for myself. Maybe after the coffee. How does the implementation... Yeah. How does it handle... Yeah, okay, cool. I've answered questions... Ooh, enough procrastinating. I think it is time to do it. Yeah, I know. 15 bucks is a good... Well, considering that I get, like, instant coffee, it's more than actually a couple weeks. That's like a couple months if you do it right. If you get the really, like... I don't know, the Dunkin' Donuts instant coffee, you can really stretch that out, I bet. But no, the coffee is out of my pocket. The thing that this money is going to go towards, every dollar that anybody donates, and I'm not telling you guys to donate, right? If you have money, spend it where you want to. Spend it learning to program, making your own game, paying for your own artists, right? If you really, really, really want to donate to me, by all means, you're welcome to, but seriously, you don't have to, and I appreciate it, don't get me wrong, but you don't have to donate in any way, shape, or form. All the money, though, that is donated is going to go towards various other people on the project that I will pay for their time. I don't do rev share stuff, because if this project falls through for one reason or another, then obviously those people would never see a penny. And so that's really something that I kind of hold in esteem, is that all the fellow artists that I work with, I'm not begging for money, I'm sorry. But all my fellow artists, I have such a high esteem for them that I would never want to have them commit their time to something and then not get paid for it. And if you are an artist and you're sitting here watching me program, don't take rev shares if you can. Take money up front, or money and a rev share, but don't take pure rev shares. Stop it. No. You guys, stop the donating. Seriously. Don't. I have a 6-figure income, guys. I can handle this on my own. Well, had a 6-figure... Whatever. Forget it. We're doing work now. We're doing real work. Okay. Dum-dum-dum. So, we need the cell width, or cells per width. Let's see here. Can I show the game right now? I don't... Would it work? Let's nuke this real quick. Just one last look at what it looks like before, just so we remember. Just so we remember what it looks like before we go in and rip it all out, right? Here we go. This is supposed to be a more yellow. Kind of looks more like beach without the yellow in it. Dynamic 3D terrain. Yeah, there's more to it, but right now all the stuff is turned off. Simply because I recently did a giant rewrite on the terrain system that doesn't really make the rest of the game work too terribly well. The terrain is looking good, I can make it look better, and that's what we're really trying to do. We're taking one feature of the game that is amazingly central, and we are just nailing that sucker down so we never have to change it again, and so that we never have to work on it again. Because I'm getting sick of going back and doing little things here and there, so that, you know, I have to keep modifying the terrain system. No, I want this done, so I'm going to write it once, or rewrite it this last time, and hopefully this will be it, right? My lack of foresight will continue to plague me no more. Is it Minecraft? No, it is nothing like Minecraft, or at least I have no plans on making it anything like Minecraft. It will have its own feature set, its own crazy stuff that it can do, and that will be it. RTS Goddess, kind of, yeah, with some different systems in place, and Goddess had terrain manipulation. I don't really want to get into that kind of set of features. That's a big thing, and it's a big thing I don't want to fight with. So we're not going to do that. I prefer the Verneuil cells in some ways. The problem is the Verneuil cells didn't lend themselves terribly well to an interesting looking terrain that was also usable and was user controllable. It was a nice idea at first, and it lent itself well to some of the systems that were in place, but it was just not controllable enough. And it just kind of fell apart near the end because the Verneuil cells were just not working out. They were a little too complex, and they weren't contributing enough to the game design to hold up their uniqueness. Alright, so, cell system. Alright guys, here we go. Womp. There that goes. And we'll end up rewriting a lot of this for now, just so I have a clear head. We're just gonna do this. As much as I hate to. Okay. And let's order this correctly while we're doing this, right? So we have a cell group, and cell group needs to, actually cell group needs to go below cell. Really? I didn't know Goddess had just, like, dropped off like that. That's really unfortunate. Ouch. Alright, so, yep, just has to be done. How we're doing it. So, standard array that is going to contain all our vertices. Vertices are still going to continue to be 2D points. So that's kind of staying the same. Same with the cell edges, I think, are going to continue to stay the same. I don't... Ah, man. Yes, the Morbid one, I upload as many videos as I can. I actually went on a big spree yesterday and the day before trying to get all of the latest ones onto YouTube. My YouTube channel is linked in the stream description, and it's got, I think it's up to 12 or 13 videos at this point of all the work from not start, but pretty early in the process all the way up. I've heard some pretty big criticisms of Goddess, so I can kind of understand why it's difficult to keep putting money into the project. Granted, I don't know if those criticisms are actually valid or not, but still, there's something to be said for it if it's having trouble resonating with its core audience. And that's kind of what I heard was the case. I don't know if that's actually true or not, but that's what I heard was the case. So you have your cell array, and this is going to be something like this, right? Nice and simple. Now we're going to keep it in a one-dimensional array, because what we need to do here is we're going to have a range of integer 2Ds. This will be the group range. And this will actually be nice for us because, remember before, Verneuil cells took up more space. A cell group is going to turn into what some of our old Verneuil cells looked like, if only just in functionality, so that we can control groups of things at once. So, say when I want to go have a guy cut a tree down, he's not going to scan and examine every single tree in the area. He's going to only scan the groups that he's standing in or next to. And that's going to initially let him find the closest trees without scanning the distant ones, without even considering scanning them. Thank you, The Morbid One. Glad you could join us, and yeah, hit that follow button. Keep watching. Same goes for anyone else who's here for the first time, has never seen me do stuff like this before. Once again, this is not my norm, but I am doing this because it needs to be done, because terrain is kind of one of the main cores of this game. It's something that is going to directly and very heavily affect how the rest of the game development arc works. And if this isn't something that is nailed down and keeps changing, my target is going to keep changing as well. And as anyone who has done any kind of archery or rifle shooting or any kind of projectile launching, shooting at a moving target is a pain in the ass. So I'm going to try and nail this down so it at least stops moving. How are these cells categorized into groups? So a group is just going to be a set of cells that is a set size. And I'm trying to hold as much information in each of the inner groups as I can, whereas before I kind of distributed the information all over the place. I want them to be as self-contained as possible, because before I was passing the entire cell system into each component so that they could calculate all the little things they needed to calculate, and I'm kind of got tired of that very quickly. As much as I liked it in some ways, it also caused a lot of trouble. So we're going to see what we can do to kind of disseminate some of that, if we can. So, okay, you're going to have cell pointers, and a pointer, or sorry, a cell is going to contain 0.2D pointers, right? So this is, we're removing some of these dependencies out now. We're doing everything we can to take some of the work off of the, kind of out of the cell system. The cell system was doing a lot of work before and was becoming not really monolithic, but it was becoming kind of the load horse of the entire subsystem, and it was a little bit much. Logic that honestly shouldn't have been in there was ending up in there, and that was a problem. So vertices, and the other thing we can do, actually, now that I'm thinking about it, is this should not be, let's see here. This will be a pointer array of 4, because, whoops, didn't mean to do that, because now cells are square. Set memory limit, right? We don't need a dynamic array anymore. We can throw that out the window. Which also means we are going to have cell edge pointers. And there will also only be 4 edges. Hey, magical. Tutu, it is a bit off topic, but I'm happy to talk about it. If I was going to make a game, would I suggest using Unity or Unreal 4? I haven't played with Unreal 4, so I couldn't tell you whether or not it was a good way to go. But I definitely like Unity, especially for someone who doesn't want to fight with all the little systems and subsystems that come with making kind of what you see me doing. it makes life a lot easier when you use Unity, I would say. Especially for smaller game concepts. If your game concept is larger, that's when I start to worry about using Unity, because Unity tends to clutter very easily. If you need evidence of that, look in their standard game object, and you'll see that they've mashed a whole bunch of variables inside of it that shouldn't always be in there. For example, you have 2D and 3D collision living inside different variables in the same object. I understand why they did it. I'm just not a fan of it. Alright. Yeah. Cool. So, cells, that's pretty much all we need in a cell definition. I guess we could go with a cell center as well, but we'll leave that out and see if we actually need that or not. Or will we? Let's leave center in there for now, and then we'll tear it out if we find ourselves not really needing it. Okay, cell edge. Obviously, the vertices that make up that edge. Also, ooh, and this is where we need to start predefining things, or pre-declaring. Sorry. Excuse my mouth. Let's see here. Class cell. Cell pointer, cells, 2 of those, 2 vertices that make up our edge, and eventually we'll want every edge to also know its own width. There we go. This is looking much better already. Cell is ambiguous. Ambiguous? What? What do you mean ambiguous? Are you actually going to keep complaining? Oh gosh. All those functions I used to have that don't exist anymore. Ah. We'll keep going. But let's see here. Cell is ambiguous. That's fine, actually. Actually, it is an actual compiler error, isn't it? Okay. Create cell. You can calm yourself. As can the create cell system. Let's also have that control itself somewhat, so we don't have to fight with so many of these errors. I think I saw 230 something. We're down to 175. Coffee kicking in? Do I talk faster? Alright. Oh god, this entire file too. Out you go. Yeah, out this goes. Oh, let's leave it. And instead, cell edge 1, cell can also go to high heck. Wow. I think Chokma is completely right. It hasn't really kicked in just how much code I removed, if only because that header file was actually kind of nice and small. I mean, look at all this. This is 500 lines of code. Ah, what have I done? Alright. From 175 errors to 73. Fair enough. Let's turn this off. I'm just kind of cutting out all the code that used the old system, just so that I can, as things compile, I can see if I'm still compiling correctly or not. Oh gosh. Do I mind talking a bit about the game? How is it in RTS? It is a real-time strategy, not in the same way that StarCraft, and this is actually a good thing to do. Get me talking so I don't realize how much code I just deleted. It's a real-time strategy in that you are, in real time, interacting with the people who make up your settlement, and you're doing not the kind of macro and micro that you might be used to for StarCraft, but instead you are going so far as to say, I need to... Okay, we're low on food. I need to send somebody out to go scout for food. Or I know this place that has food. I need to send somebody to that place. And then I need to have them scavenge for food there. Let's shift this a little higher. Min height, max height. We can actually include this giant chunk of code that's... There we go. 22 errors. We're almost done with just the rip out. And honestly, I should be marking this all with to-dos, but there's so much of it that I actually want to... I actually just want to look for the giant comments in the diffs afterward, just so I can not only see the difference in the changes I made, but see what I need to re-implement and what is more important than other things. So how is it in RTS? Sorry, I need to get back to the question. The designer in me or the programmer in me is kind of taking over a little bit. How is it in RTS? So it's a real-time strategy in that, in real time, you are forced to make the decisions of what needs to happen next. So the AI, on its own, should be able to come up with kind of the day-to-day routine of what it needs to do. So if there's a farm and nobody's tending it, one of the AI will decide, I need to go farm. So there's not really that kind of RTS element. The RTS element comes in from your control of the entire group. So you say, I need somebody, or you can even specifically say, I need you, and you can tell one person to go do something, and you say, I need you to go scout this area. And that's kind of where the strategy aspect comes in. Who do I send? And also, not just who do I send, but also, do I even send anybody in the first place? Kind of decisions I want a player to have to make. I want a player to have to think, and then I want them to also have to jump in and say, okay, I learned this information, so that means maybe an attack is coming, or this person hasn't come back from this mission I sent them on yet, so maybe they're dead, or maybe there's something deadly out that way that I have to start worrying about. Okay, almost done commenting all of my entire game out. I feel like that's the case, but it actually isn't. There we go. Things are compiling. Whew. Alright, close files. Let's get us back to where we need to be. World generation, terrain generation, nope. We're not even going to look at the CPP file until the H files are fully defined. Also, it's different from your standard RTS in that the visibility system is way different. The visibility system is not a standard, here is my dude so I can see what my dude can see. It starts with your radius on your village, and then it only expands when you set up camera towers, or when you set up, like, somebody has a radio and is actively talking on it, then you can see that person's visibility radius. Otherwise, you cannot see any of that. And that's a big thing to keep in mind, is that, if somebody leaves the camp or walks out for some reason, you will have no idea what their current state is until they get home or walk back in range of, say, a camera, or if they turn their walkie-talkie on, then they'll know. But other than that, it severely restricts what your visibility is going to look like. And that's a big thing I keep talking about, and I keep wanting to actually be the case. I haven't gotten completely to that point, but we're getting there soon. After this rewrite, it should be a lot easier to get the visibility 100% in place and done, because that is dependent on the terrain and the terrain structure specifically. So let's see here. Edges look good, cells look good. I played Age of Empires. I played Age of Empires 2 was the first one I played. And when the HD version came out, I was severely tempted to go out and get it. But I'm good at self-control, so I have managed not to so far. A map of cell groups. Here's our cell group map. I'll just call it cell groups because I don't need to name everything. It's an old habit of mine from when I worked at Sony, and we used Slick Edit in a lot of places. That Slick Edit's it's IntelliSense, so to speak, because IntelliSense is a Microsoft word, but its developer support was not all that great, and so you'd end up naming things to remember what type they were. And that's kind of why Hungarian notation exists, and why Microsoft is now phasing out that as well. Oh, right. Of course, we cannot have a map element without the specified details of what makes up that map. Specifically, let's see here. Type def key type, and the key type is going to be, whoop, I have to go to D, key type, and then the other thing we have to do is we have to have some key type const key type reference return, I think is what it was. Let's look at this again. Yeah, okay. And it's called get key type void const. And we're going to return, C4 point to D, where the group range dot max dot x minus the group range dot min dot x times 0.5. Wait. No. Plus. Sorry. My brain is slowly... I feel like I'm waking up ever so slowly. Group range max dot y plus group... Yeah. Group range dot min dot y times 0.5. Because the average of 2 points is the point between them, right? Nice and obvious. So if we're looking for center, then we just find the average on the x and the average on the y. And this is something I teach a lot of, or I guess I should say I taught a lot of intro students, was that if you can take a lot of the math stuff and you distill the math from 2 dimensions or 3 dimensions down to 2 and then 1 dimension, it's a lot easier to do math on a number line than it is in 2 or 3D space. Returning address